bigger sequence and
Okay, so you want to do it through comparison, okay? You can do it.
Yes, yes.
You're not interested in doing it. But I would like to just do one actually, okay? You should do the rest. So do these examples better. Don't leave them, okay? Go through these every single example and try to apply the methods. I think that's a really the key time to basically learn all that stuff. Okay.
Sir, is the positivity of A necessary? We have told you
Yes.
it's positive.
Yes.
How would it affect?
It was
For negative, something.
1 by 2 then under
Anyway, so if A is positive, you have A equal to 1, but A equal to 1 is not something interesting. Okay, the only interesting cases are when A is bigger than 1 and A is smaller than 1 actually. Okay. Because if A is 0, A is bigger than 0, so it could be equal to 1, bigger than 1, and between 0 and 1. Okay? Just like that could be, the other case could be that A is between 0 and 1. Okay? So let us consider the first case, when A is bigger than 1. If An is bigger than 1, can you give me a guess basically? What it should be? Give me a guess. If A is bigger than 1, what is, one of the trivial fact about A to the 1 over n?
the nth root of that number.
Okay. If A is bigger than 1, what you can say about nth root of A?
सर 0 by 1 के बीच में होगा.
It should be between 0 and 1. Isn't that should be bigger than 1?
Yes.
Always. So if A is bigger than 1, okay, the nth root should be bigger than 1. So if it is bigger than 1, it should be 1 plus something. And that something depends on n actually. So I don't know what that something is, but I'm calling it xn. Okay, so it's 1 plus xn. Okay? Where xn is a positive, sequence of positive variables. Where xn is sequence of positive real numbers. Okay. Another thing which immediately follows through this inequality is that then A should be bigger than 1 plus xn to basically n. Basically what actually I want is that I know that this A to the 1 over n is bigger than 1. I want another sequence which is
Greater than this.
and that converges to 1 for sure. And then this guy will be Sequeeze to Sequeeze to. That's precisely what I want. Okay? Anyway. Something similar. So do you agree with this that we can show inductively that this must be bigger than or equal to 1 n xn?
Yes, sir.
I guess Bernoulli inequality. We had an exercise.
I don't know his name actually. Okay. Maybe the Bernoulli inequality. Okay. So if I have 1 plus xn to the n, then it should be bigger than 1 plus n xn, and we can show it inductively. Because just think about it. That's it. This is going to be a big expansion actually. Well, here you have few terms. Obviously, you can easily show that inductively that this should be the case. Okay. And from this, I can deduce something, which is that. So can I say that? So it's like I'm saying that A is bigger than or equal to 1 plus n xn. Can I deduce from this inequality that A minus 1, okay, divided by n
Is greater than equal to xn.
is greater than or equal to xn, which is a raised to 1 over n minus 1, and which is bigger than 0.
Yes.
Right? Now, think about it. So,
Equal भी आएगा, greater than equal to 0.
greater than or
Equal to 0.
equal to?
Equal to 2xn.
No, no, no. A is strictly
Strictly
positive.
positive.
Strictly positive.
It is greater than 1.
Now just think about it. If I treat this as a sequence,
Sir, आपने
Then-
xn का value उठाया है.
जी बेटा,
xn
xn
का
का, हाँ,
1 यहाँ पे लेके आएंगे माइनस 1 होगा. xn इक्वल होगा उसके.
हम्म।
इक्वल टू होल्ड यहाँ पे रहेगी अब तक.
हम्म।
ग्रेटर और इक्वल. आपने हटा दिया.
where बेटा?
आपने xn का जो वैल्यू लिखा है a पावर 1 पावर माइनस 1.
हाँ,
ये आपने ऊपर उठाया है.
हाँ,
ऊपर.
हाँ, हाँ.
तो इक्वल ही कहाँ गई? ग्रेटर और इक्वल.
Where is it greater than or
a माइनस 1 पावर ग्रेटर और इक्वल टू xn.
हाँ,
यहाँ पे इक्वल दिए. जब xn का वैल्यू हम उठा रहे हैं ऊपर कंडीशन से.
बेटा, when I'm saying that a minus 1 divided by n is greater than or equal to xn, but xn is a raised to 1 over n minus 1.
इक्वल है.
Equal, okay? And then I am saying that this number is positive. So here I have written equality. I'm not writing anything else. I'm writing equality. So were you seeing something else than equality? I guess that there was equality before as well. Anyway, so I have this sequence which is bigger than 0, and this sequence converges to what? 0. So we're gonna say that. So we're gonna say by squeezing principle. So this guy is bigger than 0, and this guy is converging to 0. So by squeezing principle, you can say that limit n approaches to infinity, a raised to 1 over n minus 1 is going to be equal to 0, which is same as equating it to 1 actually. Okay? Did it make any sense? Okay. I don't know where this guy is stuck. Okay. I guess that a is bigger than or equal to 1 plus n xn, so a minus 1 should be divided by n should be bigger than or equal to xn, which is exactly equal to a raised to 1 over n minus 1. I have written equality, which is positive.
Yes.
And something smaller than positive and bigger than positive, so what it should be. By squeezing principle, it should be the case. Okay? Okay? Give me a smaller than 1. Give me the proof for a smaller than 1. And the hint is that try to directly drive it from this fact actually. From this fact. I don't want to write a proof for.
Sir, आप उसके लिए कहते हैं a less than 1.
So I'm saying that I want to show that if a is smaller than 1, limit n goes to infinity,
Is also good.
a raised to 1 over n is 1 actually. Okay? But I want to drive this proof directly from the proof of basically this previous part. So I don't want to write another proof. So how can I drive basically this directly?
सर ये न्यूक्लियर कन्वर्स नहीं हो जाएगी जब I guess जो xn है वो उससे छोटा है तो वो
No, I mean, what if I try to draw, forget about the proof.
अच्छा
Only this fact actually. Can I use only this fact that this is 1 when a is bigger than 1 and use it to show that. Okay. Let me just give a quick hint. So, contradiction? What do you mean by contradiction?
A is bigger than
No. I mean, okay. I mean, if you have to do contradict, assume contrary, you should assume here actually, not here. That's what the condition
Yes,
is.
condition.
Anyway, so what actually we can show, just think about it. What actually we can show that if my A is between 0 and 1, then this sequence, okay, which is 1 over A raised to 1 over n goes to 1. Do you agree with this? So if A is smaller than 1, what you can say about reciprocal? So that is going to be bigger than 1. So 1 over A is a quantity which is bigger than 1. So if I take some quantity which is bigger than 1 and raise it to 1 over n, and take n approaches to infinity, it should go to basically what? 1. Now, after this, I can just say that A raised to 1 over n is basically 1 over A raised to 1 over n. You live with it? Okay? Okay? So, so that's converging to 1. That's 1 actually. And this guy converging to 1, so that ratio is going to converge to 1.
Asal nak kata bukan? Asal nak kata bukan? Tadi try go no.
Okay. So it's fun to do such exercises then.
वहाँ पर left और right side का limit 0 पर approach कर रहे हैं.
Yes.
तो हमने
No.
अच्छा higher.
With difference. We have this difference. So this difference will go to 0 and hence. Alright, so try to have fun with these examples more, try to do these exercises as much as you can. Okay? Because some of them might be, pop an exam. So exam is important. So let's move to the results. Let's try to do some more results and define things. Okay? So the next thing that I would like to define is what we call subsequences. Subsequences. Okay. So what do you think that? What should be the meaning of? What is your guess?
Maybe a subset.
Subset of what? I mean, if the subset of sequence.
Number of terms.
If we say subset, is this a legitimate way to say that subset of a sequence? We say that subset of a range of a sequence. Just put the terms of sequence in a set and then take a subset. Okay?
restriction होगी.
उसके बीच में रिलेशन होगा.
What do you mean by capital N? I'm not talking about convergence here. I'm just talking about defining a subset.
Restriction होगी.
So here the clever way. So one of the intuition is this, that okay, you have been given a sequence like P1, P2, P3, Pk, and so on and so forth. I don't know. Okay. And I want to define a sequence or a subsequence out of it. Okay. So if I want to define subsequence, I need to pick some specific terms from this sequence and create a new sequence out of it. The sequence is going to be obviously infinite, but you can have finite number.
Next time.
No, it is going to be sequence itself.
Okay.
So sequence is a function from n to r. Okay, so subsequence is a sequence, it should be a function. Okay, okay, you can have a range finite, it's finite, right? So I need to just pick basically, say first term, and say third term, and then, the 10th term and 15th term,
K minus 1.
and, I don't know that, just take some terms, okay, and create a sequence. Alright. How should I represent? How should I write it? So the way to write is this. So if I have a sequence Pn, I'm going to say that a sequence, by a subsequence that I'm going to denote basically, is going to be Pn and K, for example. Okay? Where K runs from 1 to infinity. So, so that's a subsequence. Huh? Subsequence. Where nk is what? Where these indices should have something similar property which these indices have. So here you have 1 which is smaller than 2, smaller than 3 and smaller than 4. Okay. So how about here? Here we should have n1 should be smaller than n2 by index, smaller than n3 and so on and so forth.
So the indices should be smaller than each other, or the terms also?
No. There is no comparison of values of terms actually. The indices. So y indices should be smaller. In other words, since I am taking, for example, this as my first term, so my n1 is 1, and I am taking this as a second term, so my n2 is 3. So no matter what this n1 and n2 is, that n1 should be smaller than n2 actually. Is it making sense? Okay. So there should be an order basically in the terms of the sequences. But you need to make sure that these terms are from within these numbers actually. Okay. Or more simply, that if I have this set, which is the range of the sequence Pn, then any countable subset of this set is going to be a subsequence basically. Any countable subset of this set is going to be a subsequence. Okay? So it could be set itself. It's like you can ask loads of how many subsequences a sequence can have.
As we can think of, more than that.
So the infinitely easy answer, huh?
That is why he came to kill himself for the positive.
What did you say?
What I said? I said, as much we can think of, more than that.
Okay.
You
You can think of some basically more than that. So actually we can show, and it's a fun fact to basically prove, that there are uncountable number of subsequences of a sequence.
And sir, if we are giving...
Uncountable number of subsequences. So just think about it, that why this should be true. Okay. So let's take some examples. So keep in view better this notation. So whenever I have to represent some sequence, I'll represent by Pn, An, Bn. But whenever I have to represent the subsequence, I'm going to represent it through Pn with some index k, which runs from basically 1 to infinity. Okay, and there is an order basically in that. Take Pn to be 1 over n. Okay. me some subsequences.
It is equals to 2k minus 1.
So that's, I have 1 over n, that's a sequence where n runs from 1 to infinity. Give me a subsequence of this actually.
1 over n is equals to 2k minus
1 over
2k.
1 over 2n. Okay? So 1 over 2n. Do you think that is going to be the subsequence of this? So it's like that's 1 half, 1/3, 1/4. And from that I'm just taking 1 half, 1/4, 1/6, 1/8 and so on and so forth. So that's a subsequence. Okay? And
1 over n square.
1 over n
n
square.
square could be another subsequence of this sequence. And
1 upon
1 over n factorial is going to be
1 over n power n.
okay? 1 over n power n would be one subsequence. You can have loads of subsequences basically, and hence you can show that there are uncountable number of subsequences.
Sir, if we are given
And
subsequence,
why this should be the case? Just think about it. Why this should be the case? I mean, did you solve that exercise, which was about Cantor set from exercise sheet 3, after being 2 actually, in which you have this set consisting of 0 and 1, and you are taking the countable product of it, and you are showing that basically this countable product is going to contain uncountable elements. Anyway, it's a fun exercise to look. Why I am defining subsequence? I am defining subsequence because of some very, very interesting result. So if you have a subsequence, you can ask immediately a question. Imagine you have a sequence which is converging to a number, and you have another subsequence. You have a subsequence of that sequence. What would be the limit of that subsequence? So is it going to be this? Is it going to be same as you are guessing from here? Maybe this goes to 0, this goes to 0, this goes to 0. Okay, all goes to 0, maybe. Okay.
It should be same because they are the same terms. Almost same, they are the same terms.
It must be conversion, but
So in other words, so the interesting question would be that, is the subsequence going to converge to the same limit or different? Wonderful question actually. Okay. So let's try to answer this question. Huh? Less P. Less what?
Both are
Limitless.
countable.
No, we're going to answer this basically. We're going to answer this in a theorem, and we're going to have this. Invariance property for subsequences. Okay. What does this say? It says that if I have a sequence an, okay. So I'll try to prove this result in the terms of meter spaces. But this result is going to be a particular case of that. Okay, so if an converges, so I have a sequence which converges to a point A in the space X, then every subsequence converges to the subsequence of obviously A and converges to A. Okay? So something which is very much as expected.
Gateways.
Now, before getting further, I would like you to think about the contrapositive of this basically. What would be the contrapositive of this? And will that be useful? What would be the contrapositive?
The subsequence.
If the subsequent does not converge to A, then A and does not.
Sequence also doesn't.
I would like to have a more precise version of it.
If a subsequence is not convergent, then sequence is
Okay, so one thing is that if a sequence is not convergent, then obviously the
No, subsequence is not convergent.
If the subsequence is not
if a
convergent,
subsequence is not convergent, then the parent sequence is not going to converge. Okay,
Okay.
fine. But I want even a more better statement then.
Subsequence is divergent.
Then
The sequence is divergent.
But even better
Divergent,
statement. I want to
Convert-
have
not
even better
convergent.
statement than that.
Not so alternating.
Not this.
Alternating
How?
option.
if limit n approaches to infinity a n k is not equals to a, या फिर is equals to a, and limit n approaches to infinity a and also approaches to b, then a is not equals.
So, let me state more precise. It says that if you have two subsequences of a sequence which are converging to two different limits, you are done. The sequence is not converging.
We are done.
That's what it says. Don't you think that contrapositive is going to be that if you have some subsequences, just take two, and they have different limits, okay?
Oh,
Then
yes.
the sequence is
That
divergent.
it was for every sequence. Fine, Jesus.
The sequence is going to diverge. So you got another criteria basically.
Yes.
So you have definition to prove something to be divergent. You got another criteria to prove something to be divergent actually. Okay. Let's prove it. So I would like to. So let A and K. Let A and K be a subsequence. Subsequence of A n. Okay. What should I do? I need to prove that this A and K is converging to the same limit A. Okay. And whenever you want to prove convergence, what you want to do? We want to play a game. The game of
epsilon.
epsilon and n. So, for a given epsilon, we need to find an n such that this A and K converges to n. Whenever n k crosses some basically. Okay. So, for a given epsilon, positive, I don't know whether there exists such an n for this subsequence, but I know one thing, that since this guy is convergent, there must be some n which, there must exist some n for which you can say that a minus a, difference between a and minus a is smaller than less than epsilon. So there exists a capital N such that the distance between a and a is smaller than epsilon for all and greater than or equal to n. Okay? And now I want what? I want to compute the distance between a n and a n k and a. What do you think that what should I do?
It should apply triangular inequality, I guess. Triangular inequality.
Triangular inequality?
So we are getting contrapositive. So we are going direct proof.
Okay. So what should I do?
अगर कोई subsequent है epsilon, कितने हो सकते हैं? नहीं, नहीं।
there is a subsequence.
ये तो क्या कंटेन कर रहा है इसमें
Images के images में करते
Obviously, the range of subsequence is going to be contained into the range of the sequence.